Hello, in this session we will be learning how to convert a non-deterministic finite automata to a deterministic finite automata. What is the motivation, why we need to convert, and then the method of subset construction we will be discussing with a working example. So the motivation, conversion from the NFA to DFA. If both NFA and DFA recognize exactly the same language, then why does the industry almost always implement the DFAs instead of the NFAs? And then how to convert the NFA to DFA using the subset construction method. So up to now we have discussed this NFAs and DFAs from a theoretical perspective. Now let's connect this idea to something you use almost every day. AI systems like ChatGPT, Google Search, autonomous vehicles. I'm not saying that these systems are NFAs. Instead, they follow a similar idea. First, they explore several possibilities, then they commit to one action. In AI, there are multiple possible interpretations. In AI, there are this candidate hypothesis. The model evaluates which interpretation is most likely. Once the intent is identified, the software no longer explores possibilities. It will follow one deterministic workflow. So when we solve a problem, our brain naturally thinks of multiple possibilities at the same time. Computers don't. They want one instruction at a time, no ambiguity. So while planning, our mind explores all possibilities. This is exactly how an NFA behaves, such as planning. When Google Map computes a journey, does it immediately choose one route? No. It first evaluates many possibilities. Once the navigation starts, Google Maps gives exactly one instruction at a time, and that is deterministic. Finding all possible interpretations and possibilities of an answer to a question asked to the ChatGPT. When ChatGPT receives a question like book a ticket, internally it considers booking the ticket from the source to destination using multiple options like flight, train, and bus. So multiple possibilities are there. Once the intent becomes flight, once you enter I need the flight mode, then everything afterward it becomes deterministic. Similarly, can a computer literally follow all possible paths simultaneously? No. So that is why we convert the NFA into DFA. When ChatGPT generates a Python code, who checks whether the syntax is correct? Compiler. So the compiler's lexer, which recognizes the tokens, is implemented using DFAs generated from the regular expressions. So let us now do one example where we understand to convert the NFA into DFA using the subset construction algorithm. So for A plus B the whole star AB, the NFA diagram looks like this. So the subset construction method is used to convert from NFA to DFA. Why do you think this algorithm is called subset construction? In an NFA, after reading one input symbol, the machine may be in more than one possible states. Suppose Q is equal to Q0, Q1, Q2. After reading one input symbol, where the NFA will be, starting symbol will be Q0. But the NFA can do the transition to multiple states for a single input. So the options can be Q0, Q1, Q2, Q0 and Q1, Q0 and Q2, Q1 and Q2, Q0, Q1 and Q2. Notice something interesting? The NFA is not represented by a single state anymore. It is represented by a set of possible states. These are the elements of 2 to the power q, that is called the power set of the q. So each subset becomes one set of the DFA. Notice that the DFA states are not individual NFA states. Each DFA state represents a subset of the NFA states. That's why we call it subset construction. Can you say if an NFA has a 4 states, what is the maximum number of DFA states we can have? Yes, by using the power set formula, 2 to the power 4, that is 16. So the power set gives the maximum possible number of DFA states. In practice, many subsets are never reached from the start state, and those unreachable subsets are simply ignored. That is why the DFA is often much smaller than the 2 to the power n. So this is the step-by-step process for the subset construction. So we will see it with an example here. So given this NFA, first we will draw the state transition table. In state transition table, we will consider all the 3 states Q0, Q1, Q2. And then from Q0, what is the transition with input A, we will fill it in the cell. For Q, the answer is Q0 and Q1. So here Q0, if it is A, then we can go to both Q0 and Q1, and that's why we have written it Q0, Q1. From Q0, if the input is B, then we go to only Q0. That's what it is here. Similarly, fill this transition table. The phi here means, that means there is, say from Q2, there is no transition with the input A or B, and that's why it is phi. Note the phi is different from the epsilon. Now, after this state transition table is drawn, we will make another state diagram. This will be for the DFA. How to do that? First, start with the start state, which is Q0. When we do the Q0 with the input A and with the input B, these are the 2 cells filled. Now if you see here, there is a combination of state in one of the cell called Q0 Q1. That we will consider in combination the Q0 Q1 and see where does it transit when we take the input A. So from the Q0 A, we get Q0 Q1, and from Q1 A, there is nothing. So total is Q0 Q1. From Q0 Q1, when you have a transition B, Q0 B, we go to Q0, and from Q1 B, we go to Q2. So we have a combination Q0 Q2. Now again take the Q0 Q2, because here if you see these combinations, all the combinations have to be considered in the Q states. So initially when we had Q0 Q1 as one of the combination, we put it in the Q column, and then we fill the table for that Q0 Q1. Now this Q0 Q2 has not been considered, so here we add the Q0 Q2 and see the transition for the A and for the B and fill it like that. So now this state diagram is for the DFA. So we draw the DFA. So how many Q states we have? Q0, Q0 Q1 as one state, one new state, and another new state is Q0 Q2. So now you draw this diagram that will be denoting that of the DFA. So this is one of the assignment. Try to convert this NFA to the DFA. And here this is the start, and here this is the final state. So here if you see that Q0 is the final state, and hence wherever the state is having, the combination state is having Q2 is also made as a final. So this is the solution. These are the references. So in the next session, we will learn about the DFA minimization. Thank you.